I recently shifted to this new place and I'm still setting up my workshop. There is a lot of I need to buy, but something I would rather build myself. Like this, right now my dustbin is literally a cardboard box, so I decided to make something that actually fits my style. A dustbin that opens like this. The idea sounded simple, but the designing this mechanism way harder than expected. After finalizing the design, it was time to print everything. For this task, I'll use my all-new Bamboo Lab H2D. After about 16 hours of printing, this is what I got. All the parts came out incredibly clean and honestly, I couldn't wait any longer, so let's start assembling. First, I put together the iris mechanism to test if everything lines up. It's a simple assembly, but this is where things can actually go wrong. So far, everything looks smooth. Now I just need to add the remaining blades, and they are too many. Okay guys, as you can see, the mechanism works perfectly and it looks even better than I imagined. Next, I moved on to the base. I designed this slot at the corner to hold magnets so the bottom can snap off and on easily. I'm using these neodymium magnet for strong hold. Just align the magnet on top of the slot and gently press it with a hammer or something similar. Next, I stacked another set of magnets on top. Align the main enclosure carefully and press it down so the magnets transfer perfectly into position. This ensures both sides are perfectly matched, and now the bottoms snap on and off cleanly. Secure but easy to remove. Simple, right? Next, I added the top ring followed by the iris mechanism. And just like that, the enclosure is complete. It's looking really clean this time. Please don't tell me this one looks like a washing machine too, like my previous version. Jokes apart, now it's time for the electronics. The setup is pretty simple. We need only 4 components. First, an Arduino Nano, the brain of the project. Next, a servo motor to drive the iris mechanism. Then an ultrasonic sensor detects your hand and triggers the opening, and finally a charging module to power everything. And one more thing, I picked up all the components for this build from robo.in. They got a huge range of electronics, tools and modules for DIY projects like this. If you're planning something similar, definitely check them out. The links is in the description. Coming back to the topic, this is the wiring diagram we'll follow for all the connections. But to keep things clean, I'm using a custom PCB. It's actually from my previous version of this dustbin and it fits perfectly for this build too. So let's install all the components and get this ready. The PCB is in place. Now it's time to upload the code. It's pretty straightforward. Just select the board, choose the board and upload the code. Wow, it rhymes. Now let's plug the battery and test it. Something's off, right? The servo isn't responding properly. I guess it's because servo and the Arduino Nano need a stable 5 volt, but this battery only gives around 4.2 volt when fully charged. So yeah, that's not enough. To fix this, we need a voltage booster or something like that, and luckily I already have this module. It's a charging module that also gives a constant 5 volt output. Perfect for this. So let me quickly swap this in. Alright, let's test it again. And there you go, it's working perfectly. Now we can finally mount the servo motor into the mechanism. Okay guys, now the servo is ready to be installed. First we need to zero the servo. Just power on the circuit and it will automatically move to its default position. Now make sure the mechanism is fully closed, then place the servo exactly like this and secure it with screws. As you can see guys, everything is working perfectly. Now before we move on to the final assembly, a quick shout out to Altium for sponsoring this video. If you are a student and want to learn how to design your own electronic from start to finish, the Altium Student Lab gives you free access to professional design software. You can create schematics, design PCB layout, and learn how real PCB boards are made. They also provide step-by-step lessons and hands-on projects so you are actually building while learning. And the best part, it's completely free for students. If you're serious about your electronic career, click the link below and join Altium Student Lab today. Coming back to the video, let's do the final assembly and complete the build. So finally guys, the project is complete and it turned out exactly how I imagined. It looks clean, unique, and matches my vibe. As you can see, everything responds instantly and the opening and closing of the mechanism feels incredibly smooth. Honestly, this is one of my favorite builds so far. If you want to build one yourself, all the files are in the description. Feel free to check them out. That's it for this video. If you enjoyed it, don't forget to like, comment and subscribe for more builds like this. Thanks for watching and I will see you in the next one. Until then, bye bye.